So part 3, now the concentration of KOH in moles per dm cube. So that's the molar concentration, alright? Alright? Given was the mass concentration of KOH, which is equal to 13.44 grams per dm cube. Right? So what we really need to do here is just simple to convert the mass to moles. Right? So to convert mass to moles, we're going to need the mass, mole, molar mass. Right? So it simply means that this is unknown. The mass, we have the mass which is 13.44 grams. The molar mass is what we can calculate. Alright, so it's going to be equal to potassium is what? 39?
Yes, sir.
Plus 16 for the oxygen plus 1 for the hydrogen.
56
grams per mole. So it simply means that 1 mole of potassium hydroxide or 6.022 times 10 to the 23 potassium hydroxide would weigh 56 grams. Alright? Now, we need number of moles here, right? So from this statement here, we are saying that 56 grams of KOH equal to 1 mole, right? So X grams of KOH is equal to, so 13.44 grams of KOH is equal to X moles. And the mole is the unknown in this case. Following? We have to know what is the unknown. I was going to put that X here, but no, in this case, it's not like earlier when I was giving you the example. Here we have the mass and we need the moles. Alright? So this is X is equal to 13.44 times 1 divided by 56. It's equal to
0.24, sir.
0.24.
Yes, sir.
Right? Therefore, concentration molar concentration of KOH is equal to 0.24 moles per dm cube. Because it was 13.44 grams per dm cube. And we convert this grams to moles, we get 0.24 moles. So 13.44 grams of KOH is the same thing as 0.24 moles of KOH per dm cube.
It's the same thing.
The same thing. And the moles of KOH, alright? Using the titration. Alright, so based on this, the concentration in moles per dm cube is 0.24. What was the volume using the titration of KOH?
13.4.
Come on, read it again. Read it again, please.
25.
Good.
Come on, you have to read the question and jot down this stuff, alright?
Alright.
So the volume for the KOH is the one they did from the pipette, which is equal to 25 cm cube. Alright? So they want the moles. So we have concentration, we have volume, and they want the moles. So from the concentration, we know that 0.24 moles of KOH is in 1000 cm cube. So X moles of this is in 25 cm cube. Cross multiply x equal to 25 times 0.24 divided by 1000.
0.24, right? So the answer is 0.06.
A balanced equation for the reaction. Remember that you should go home, review the titration calculation, alright? And try and practice some more questions, alright? So 5. So it is a sulfuric acid, which is H2SO4 AQ plus potassium hydroxide AQ. Produce salt and water. So the salt is potassium sulfate plus water, right? Remember that alkaline plus acid is going to equal to salt plus water, alright? Now to balance this equation, I believe you're going to need a 2 here and a 2 here. So remember that sulfuric acid would be a dibasic acid, so 2 protons. Potassium hydroxide is just 1 OH minus per mole. So that is why we're definitely going to need 2 of this per mole of acid, because it's 2H plus here and 1 here, 1 OH minus. Following? So we're going to need 2 moles of OH minus to react per moles of sulfuric acid, because it's 2 protons per mole of sulfuric acid in the compound. Alright? So the physical state, so this is aqueous liquid, and then the 2 in front potassium hydroxide, the 2 in front the water will balance the equation. Right? This is 2 hydrogen, 2 hydrogen, which is the 4 hydrogen in water. Then we have 4, 5, 6 oxygen, we have 4, 5, 6 oxygen. We have 2 potassium, 2 potassium. Clear?
That's not a redox reaction.
It's an acid-base reaction, but technically it could be a redox. No.
It has to have one element, a pure element.
Not necessarily, just the oxidation state should change, but no. Because this is H is 1 plus, that's 1 plus.
So you say you get 2 moles of potassium.
So we can
To balance it?
Yeah.
Yeah, to balance it, remember this is balancing equation because this formula is K2SO4. So it's 2 potassium you need over here. 2 potassium is over here, based on the formula.
Based on the because
Because potassium is plus and sulfate is 2 minus.
So, yeah, that one I was.
So you're going to need 2 of this to balance that equation. You see? Likewise, the sulfuric acid, H plus is 1, so 4 is 2 minus. So you're going to need 2 protons per mole to balance the equation. Alright, so moving on, determine the number of moles of sulfuric acid in the volume of solution using the titration. Alright, so remember now, we don't have the concentration, but we know the number of moles of KOH and we know the balance equation, and we have the balance equation. Therefore, we can calculate the number of moles of sulfuric acid. Following? From the balance. There is 0.06 moles of this was used.
So that is 0.
So to get the number of moles of this, you would have. Clear? That is a 1 to 2 mole ratio. You following?
Yeah, man.
So number of moles.
That is 0.3 then. 0.03. So we calculate it.
Equal to the number of divided by 2. Alright? Since mole ratio is 1 to 1. It's 1 to 2. Mole ratio 1 to 2. So this is 0.06 divided by 2 equals to what? 0.03?
Oh, that's why I say 1 to 2 with the first equation with that is.
Alright.
Okay, do it.
Calculate the molar concentration of sulfuric acid. Alright? So now we're gonna have the moles of sulfuric acid and we're gonna have the volume. So we can calculate the concentration. Following? No man, you're following man. Don't say that. Because the same three stuff I spoke about earlier. So V
Yeah, may have too much things and different things.
So
we use the 0.03
concentration, volume, mole. Those are the three quantities we interrelating. We know the volume from the what we calculated up top, which was equal to what? 14.3. Because remember that this is for H2SO4, which was in the viewer. Those readings. Following? The concentration is what they want. The molar concentration is what we don't have. And we have the moles, which is what?
0.06.
No.
Sorry, it asks for sulfuric acid though.
So 0.03.
Molar concentration.
Remember that was the potassium hydroxide was 0.06, you know, then we calculated the moles of sulfuric acid, which was divide this by 2 to get 0.03. Now, Mr. Harding, if we have if we have volume and we have moles, can we find concentration?
Yes.
Yeah, man, yes, it's not a guessing thing. Remember that these three quantities are interrelated, so if we have two, we can get the third.
Man can't get the idea.
Alright? So 0.03 moles is in 14.3 cm3. So X moles how many cm3 we talk when we want concentration?
Thousand.
Good, 1,000 cm3. 1,000 times 0.03. I mean, that's in moles per 1,000 cm3 or moles per dm3. The answer that we get here.
30 divided by 4.
Which is?
30 divided by 4.
Which is what?
So you're using okay. So the answer is 2.97. Sorry, give me a large number there. Hold on a minute.
30 divided by 14.3.
Divided by 14.3, yeah. No, exactly get
2.098. That is it to the second or the third.
10 to the minus 2. So that's basically 0.02.